Thanks so much for joining me here on the dev stage. It's hard to go head-to-head with Adoni and all the alpha that he's going to be dropping over there, but I promise you the real alpha for the real builders, the folks who are making stuff to happen behind the scenes is going to be here. So I'm really, really excited to kick off an entire day of great content on the dev stage here. So my talk today is about radical interoperability. So this is sort of a way I think about how to stitch together a lot of the stuff we're doing at the core level and some things I'd like to see us do from sort of the community level. And so I'm going to start off with a little bit of background to explain what I mean by radical interoperability. I'm going to go into some of the tech foundations of Sui and how it enables it. And I'm going to ask for a lot of help from you all in terms of what we need to do to make this happen and to build towards something really amazing. So to start off, I want to talk about the technical value proposition of Sui. So what is it that Sui lets you do that you can't do with conventional APIs and conventional apps and basically techniques that existed beforehand? So I'm going to explain that by comparing and contrasting what existed before to what we can do with Sui. So if we think about a conventional app at a very, very high and oversimplified level, there's basically three different parts to it, right? There's a database, there's some API that mitigates access to that database. It might fetch data, it might do some computations, it's doing authentication, whatever. And then there's data that comes out when you call the API. And so if you call the API, what it's giving you is a copy of something in the database or a derived computation that comes from some values in the database. And so if you have one app, it looks like this. And then if you have a second app, the picture is going to look very much the same. There's a separate database, there's a separate API, there's a separate copy of data. And so because these apps work by having separate databases, they don't necessarily understand each other's data formats. And it's not necessarily going to be the case that you can call API 1 and get some data and then pass it into API 2 or otherwise get the apps to understand each other. They're not going to be interoperable by default. So let's look at the way the picture looks with Sui. So very similar. There's a database again. There's an API again. But here it works a little bit differently where you're going to make a call to the API and it can return a copy of the data just like a conventional API, but also it can return an object that's moved out of the database. It's not just you're getting a view of what's in there, like you actually get handed back something that could be a coin or an NFT or an object or a credential. So that's something that's quite powerful and quite different. It's not, you don't only have copies of data, you actually have, tangible things that exist in exactly one place that you can have ownership over. And the other thing that's really cool and really different is that instead of every application having a separate database, you have a shared database. So you define your API, I define mine. On the back end, they're actually talking to the same database. And so that means you can define your API in terms of types that I've declared. And if you do that, you can take objects returned from your API and just plug them right into mine. So you sort of get this interoperability by default where by virtue of having a shared database and by having data formats that everyone can understand, you get way, way more interoperability in theory than you could have in a conventional application. So, looking at this picture, an object, obviously that corresponds to a Sui object, plus maybe dynamic fields hanging off of it. An API is a move package, and then the database is Sui and now Walrus, which is an amazing extension. And so, summarizing this, like what I think about is the Sui technical value proposition compared to before. Number one thing is instead of just getting copies of data, you can have objects that have genuine value and that you have ownership over. And I think this use case is very well established. We all know about tokens. We know about NFTs. People are doing this on other platforms. It works best on Sui, but I don't think we can claim we're the only ones who can do this or do it really well. But then this interoperability thing, I think, is something that is just emerging. Like we don't fully understand how it can work, what value can it provide. And I think here, especially with the addition of Walrus, of Seal, of Nautilus, there are really things you can do in terms of this radical interoperability on Sui that you cannot do elsewhere, and that can really change the way things are working, not just in the Web3 space, but more broadly. So the outline for this talk is I'm going to talk about radical interoperability, which I think of in sort of three different tiers. So interoperability across code. The technical underpinning for that is MVR, or the move registry. Interoperability across dApps. And so I think the key tool there is PTBs, or programmable transaction blocks. And then I think the thing that's emerging and really exciting is about interoperability between applications that are living outside of Sui, stuff that already exists in the world. And the things that are going to help there are the combination of Nautilus along with Walrus and Seal. So let's start off by jumping into the MVR part. So MVR stands for Move Registry. It's a very, very new thing that we are just rolling out this month. And what it does is very similar to if you're familiar with crates.io or with NPM or your sort of favorite package registry in a non-Web3 programming language. You can give names to a package, you make it easy to download and use, basically. So in detail, you have a Sui name, you can bind it to the mainnet and testnet ID of your package. You can also connect it to the source code. You can add contact info, bug bounty programs, your docs, your logo, all these sorts of things. You go to moveregistry.com, you can search, you can discover packages by name, and do all sorts of other things. So here's a couple of the problems that you can solve with Move Registry that you couldn't before. So I'm going to feature Scallop very prominently here because Scallop has done a great job of putting all their packages in Move Registry. If you want me to shill your code, get a Move Registry, and you'll definitely be up next. So if you have a question like, what's the package ID for Scallop? MVR solves this. You have the ID, you bind it to a name like lending@scallop-core. This is sort of GitHub style, where you have an org like Scallop, and then there might be a sub-org or repro like core, and you have a project like lending. You can then take that name, and if you want to build against that package in your Move code, you're writing some code, and you're like, gee, I really wish I could call Scallop here. You just say MVR add the name -- whatever network you want to depend on, and now you can call it right from your code. It's as easy as adding a use of the relevant module. Another thing this lets you do is, it used to be very, very painful to switch between mainnet and testnet versions of the same code because they have different package IDs. You have to find out what both of them are. You comment and uncomment them in some file. It's a real mess. Now you can just change the network variable in your move.toml file, and it's really, really easy to switch back and forth. And then finally, and maybe even most importantly, finding package source code. We have an ecosystem where everything is based on transparency, trusting code rather than people. You can read the bytecode, the decompiled bytecode, but if you really want people to know what you're doing and understand it and find bugs, you got to link to the source code. So also the most important part of the MVR registry is you link directly to the source code. So you can go to GitHub, file issues, contribute, see what's coming in the next release, all the things that we know we can do with GitHub. The other piece that we get with MVR is that you can add these third-party package signals. So the package metadata is something that the author can add. These third-party signals are something that others can add. So there's this SIP that everyone should look at about the attestation registry that's proposing how this can work. But for example, if you're an auditor, you could add a signal to every package they reviewed. And then if you're a wallet, you could do something like, hey, I only want to use packages reviewed by AutoSec because I think they're a great auditor and I trust them. You could also do things like Asymptotic is looking at the ideas of, I want to attach formal specifications to packages, and then maybe I want to incentivize creation of new specs and have a sort of economy working there. That's a really cool way this could be used. You could also do something like, I haven't talked about Nautilus yet, but if you want to have a verified source, today that's the responsibility of explorers, but what you could do instead is add an attestation to the package that says, I've verified that this version has this source, and then everyone can just consume that instead of each explorer having to do this in its own sort of ad hoc way. So this is a really, really exciting thing. This doesn't exist in NPM or crates.io or these other packages. You can have review systems. I think it's really powerful to be able to attach third-party information, not just first-party. So the other thing that MVR lets you do is, so you bind package IDs to names and then code, but you also have runtime data, deployment data. Every Move package is deployed in exactly one place, so you know everything that's happening with it. So this will tell you things like, we call it the interop transaction count, like how many transactions are happening that are using your package in a composable way paired with some other package. You can see if your package has multiple versions, how much traffic is flowing through each version, so you sort of know what maintenance you need to do. You can see the dependence of each version. You see sort of the dependence by name here for this particular package. And so it lets you know who you need to coordinate with on upgrades or who might be a good person to know. And this too is something that is unique to MVR. Everywhere else you might deploy a package in many different places, or you might not have visibility into who's calling it or how it's being used. And here you have, because everything's on chain, you have the canonical source of that information, which is super cool. So I said I was going to ask for your help. Here's the first part. So number one thing, please register your packages on moveregistry.com. If you have dependencies that you have, please bug them, get them to get in there as well. We're not going to stop bugging you until MVR is broadly adopted through the ecosystem, and then open source is the default in Sui. I think this is really, really important for the future of the ecosystem. And so if I talk to you this week, if you talk to people on our team, they're going to be bugging you about this, please just go ahead and do it. Use MVR and your move.tomls and your PTBs. And also add a CI job to make sure that this keeps working. In CI, you want to do MVR add and Sui client verify. This is testing that when someone tries to depend on your package, then that just works out. And finally, take a look at that SIP and comment on it. We need feedback to see that this thing can be used for all the use cases I described, but also things that we haven't imagined yet. This is only a preview of MVR. Manos is giving an excellent talk later. He'll go much, much deeper into the details. I'm really looking forward to that. Okay, let's talk about part 2, composability across dApps via PTBs. So MVR is very new, out in the last month. PTBs are older. I'm guessing everyone in the room already knows about them, but I think we can't overemphasize how important of a feature this is. I think it's really the thing that has let apps on Sui be different and more powerful than elsewhere. So I'm still going to talk about it. So PTBs let you dynamically and atomically compose move calls. So a PTB can contain up to 1024 move calls. Actually, I think Juicy discovered it's only 1023 because of a bug, but we'll fix that. There, you can do heterogeneous composition of different packages using Sui objects as glue. Package A returns an object. Package B takes an object of that type as input, just like I was showing in the diagram at the beginning. And finally, I think most importantly, you can do dynamic construction on the client side, which means that instead of only deciding what to do based on on-chain data, you can do off-chain data and off-chain compute. This just greatly expands the possibility of things that you can do. If you look at things like some of the powerful aggregators we have, they're doing really fancy route searching to find the best possible route. They're stringing together PTBs that have tens or hundreds of calls to get you the best price. And I think that's just the tip of the iceberg of what you can do. Here's some example code showing a simple PTB with Scallop. Thanks again, Scallop, with MVR. But I'm sure everyone has written a lot of code that looks like this and is maybe even more complicated. So conceptually, I think of PTBs like this. They solve what you might call the Expedia problem. So let's say you're somebody and you want to buy a Chicago to New York train ticket, and you also want to get a New York hotel, and you also want to get a museum tour. So each of these purchases, you ideally only want to get them if you can have all of them succeed, right? There's no point in getting a museum tour if you can't get to New York in the first place. And so in this setup, the way you'd like to organize things is that you have vendors who are providing train tickets or hotels or museums or whatever else, and they shouldn't need to integrate with each other or implement any common interfaces or even know about their existence. They're just trying to sell something. And then you have aggregators who are looking at what's offered by vendors and then looking at a query from a client and trying to figure out, based on the client's preferences and pricing and other information, what is sort of the best deal. And they want to do this, again, without coordinating and also without asking permission. So in this setup, the vendor is a move package and the aggregator is a PTB-powered dApp. So again, things like the DEX aggregators we see in the ecosystem today follow this pattern, but I think many more things can be captured by this in the future. So the last thing I want to say about PTBs is that this isn't just a theoretical thing. When we look at the data, PTB-powered interop is happening. It's very common in the ecosystem. The number of PTBs that are using 2 or more packages, not including Sui framework, that would be trivial, is between 15 and 20%, and we generally see it rising over time. And the number of PTBs that are using 2 or more commands is well over 50%, closer to 80 on a typical day. And I think if we're successful, if the radical interoperability vision is real, we're going to see these numbers increasing, and we'll see interop as being even more ubiquitous. So how can you help with PTB-powered interop? Similar call to action here. So register your packages in MVR. That lets other people call them by name and makes it easier to use your package. Write your code in a PTB-friendly way. I think most people know these recommendations, but returning objects instead of transferring them is one important thing. Another thing is don't return references, because today you can't use references in a PTB. We'll fix that in the future, but for now, that's not going to help you. Also, be aware of your dependence and coordinate on upgrades. This becomes more important with MVR because you can depend on a package without caring about what version it is, so then you'll just automatically flip to depending on the new one, so it becomes more important to make sure that things still work after an upgrade. And then finally, there's a different SIP about making PTBs more powerful by Kevin from Aftermath. This is looking at how can I have a PTB where parts of it fail, but the rest of the PTB still succeeds. This is really important for use cases like I want to do a payment and the payment will go through even if the operation I'm trying to do doesn't succeed, and many other use cases. We really need your feedback there to make PTBs more powerful. Okay, finally, let me talk about interoperability across apps via Nautilus and the combination of Walrus and Seal. So the way I think of Nautilus is it's using TEEs or trusted execution environments to do what you can't do with smart contracts. So in a smart contract, you can't call an external API. You don't have access to the internet, and that wouldn't be deterministic. From Nautilus, you can, and you can return the result and put it into Sui and check that that's what it was. A lot of times people ask, I want a smart contract that can produce a cryptographic signature. I want a private key inside my smart contract. You can't do that. You can do that with Nautilus, though. Also, performing private computation. Nautilus, a TE instance can have a public key associated with it. You can use that to encrypt inputs and have the TE do private computation over those inputs and return a public or encrypted result. you can't read or write Walrus from Sui. You have to do that from an external app. And so it's really great to do that from Nautilus if you want to produce data that is guaranteed to have a certain structure. So TEs can't do everything. It's still not good for long-running compute. Don't use them to try to train machine learning models or anything like that. Or also anything where you have to handle lots and lots of input or output data. That's also not going to be a good use case. Joy has a really excellent talk tomorrow on Nautilus. I encourage everyone to attend that to get sort of a deeper picture there. So then Walrus and Seal. The way I think of these is that they enable sharing of data across trust boundaries. So in Seal, you have data that lives somewhere. It could be in Walrus, it could be in S3 or some external data source. And Seal lets you implement an access control policy for that data using arbitrary move code. So you can implement policies like only the owner or the person that uploaded the data can use it. You can say someone can look at this data, but only if they pay me $5. You can say someone can look at this data, but only if they have this particular object or NFT. And you could also do things like data swaps. I'll show you your data if you show me my data. This kind of stuff is crazy. You can't do it. You can't do it with existing infra. And importantly, accessing data, the access control policies are on-chain, but they're evaluated off-chain. It would be way too much to send a transaction every time you want to do a read. So that's a very clever design of Walrus. I'm sure Ben will talk about that more in his talk on Seal later. Carl is also going to talk a lot more about Walrus, tell you about what's going on, about some of the future features coming. So it's important to note about Seal that it's a generic secret management system. It's not tied to Walrus. As I said, you can use with other storage systems, but it's especially good when paired with Walrus because Walrus guarantees the availability, the immutability, and the provenance of the data that you're using. So a lot of times, like these fit really well together. Okay, so how do these pieces fit together to enable interop across apps and between apps and dApps? So I'm just going to very briefly talk about two different patterns. So between an app and a dApp, Nautilus lets you bring some data from an external API into Sui or into Walrus. So for example, if you wanted to build something where you have Sui wallet actions that are triggered by Twitter posts, you reply to someone and say, I want to tip this person, one Sui or something, then you can use Nautilus for that. Like you're scraping the Twitter API, you're looking for the action, you're checking the Nautilus attestation, and you're making that happen. So this is useful for like the app-dApp interaction. Then for app-to-app interaction, if you have a conventional API and you have some data in your database and you have some data in Walrus, then you can use Seal to control which apps can access the data that's inside of Walrus and under what conditions. So you could do something like leveraging Seal to share data between app A and app B. So this stuff is all very new. Nautilus we announced 2 weeks ago. Seal, I think, is about 3 weeks old. Walrus is barely a month old. So we're still figuring out a lot of the patterns of what can be used. None of this is in mainnet except for Walrus. And so I'm really, really excited to learn and hear from you, like what's possible and what's useful. Okay, so to conclude, summarize what I've discussed about radical interoperability and what I think the next steps are. So for MVR, it facilitates move package level interop as well as package discovery, package analytics, and via this attestation service, package reputation. And so we really need your help to make MVR ubiquitous and to switch Sui to being an ecosystem where open source is the default. I think that's a really important step. PTVs, they enable dynamic and atomic composition of move calls from the client side. I think we all know and love them. Nautilus and Seal and Walrus, they bridge the API and data gap with external apps that just previously made it hard to do anything that wasn't just bring the whole app inside of Web3. And I think people in the space, when they talk about this, I think it'll be like, oh, we'll just take everything that exists in the real world and we'll bring it into Web3, or we'll disrupt the Web2 version with the better Web3 version. And I think it's, that may or may not be true, but I think it's probably not going to work that way. And if it does, it'll be very, very slow over a long time period. It's much better to take things where they are today and see where we can add value via interoperability, via putting Sui, Walrus, Seal-powered stuff under the hood. And so I think that's the direction I really want to be pushing in as Mistin and to see the ecosystem working on. And I'm especially excited about, it's very hard to change the way applications are designed or the way developer behavior works. But there's something else going on in the world that we all know about that's already doing this. Like every developer who doesn't want to get fired is trying to look at how do I change my workflow and the way my app works and the way my system works to incorporate AI. And in a lot of cases, you have AI models that are smart, but they can't actually do anything. So a lot of what they're doing is a lot of their effectiveness is going to depend on how good can interop with external tools and external context be. And I think there's a lot of things that we can do to facilitate that and hop onto this change that's already happening to have our technology help. So that's all I had for today. Thank you so much for listening, and enjoy the rest of the talks on the stage.